Okay, I just have a quick question. You don't have to do it. But on like 33, do you just multiply like...
So 34 is, actually, we're going to end up with a trinomial times a trinomial here. Total of 9 products to follow through here. There's just the first set of 3 products. So I'll try and color code this. We have 2x to the 4th. Okay, and then minus 2x cubed. And plus 4x squared. Okay, switching colors, let's get the next product here. We'll go orange. Yeah, rainbow time. Negative 3x times the whole second trinomial will give us our second set of 3. So negative 3x squared, or cubed I should say, plus 3x squared, minus 6x. And let's do the last, we'll go purple this time. Nah, gray.
Do the rainbow one.
The rainbow thing?
Yeah. Oh, never mind. I don't do that.
I like it. So, final rainbow. Oh, it's just one color. It's kind of gradiated though. Thankfully it's 1, so we just get the whole thing thrown back at us. You'll get 1 times that trinomial will be x squared minus x and then plus 2. See how it's kind of like a typewriter. Every time we go through another trinomial distribution, you get kind of less and less degrees going in the variable. And so to bring this down in combined like terms here, we end up with 1x to the 4th term. Here we get combined negative 5x to the 3rd. 4, 3, and phantom 1 give us 8x squared. And right here we end up with negative 7x. And then just one constant plus 2.
Okay, so is that vertical?
So that's an example of vertical alignment. Distributive property here. Notice there's no sign in between here. It's just multiplication. So we start by really an extensive foiling process, maybe more than you've ever done before. I'll do this one color at a time. We get 2x to the 4th. Second product is going to be 2x to the 3rd. And the third product there is 2x squared times 1. Okay. Switch the color up. Let's see what we get with the middle one. Negative 3x times x squared. So that's negative 3x cubed. And we get negative 3x times x, so negative 3x squared. And finally negative 3x times 1, so minus 3x. Alright, and final set of rainbows. 1 times all 3 of those, that'll be quick. You'll get x squared plus x plus 1. Alright, so we're just dropping down all of these like terms and combining them. Keep in mind the phantom 1s. And we end up with 2x to the 4th minus x cubed. Let's see here. Hey, does that one zero out? I think that one zeroes out. I'm just going to... And then minus 2x plus 1 is all by itself. So there is the expanded form. Okay, here you want to look at, it says in the directions, factor out the common factor. The first question we have to understand is, what is a term? How many terms do I have in this whole in this whole entire expression. And does anybody know how many terms I have there? Yeah. There's this big term, there's several factors involved, and this big term. Terms are separated by addition and subtraction. So in each of those terms, I have a common factor, x plus 3. So we're going to write that out front. And like when we factor anything else, when I pull that out front, you look at what's left over where they came from, where the factors came from. So I have a 2x and then a minus 5 left over. So now we've factored out the common factor, and you're done. Recall that a squared minus b squared can be factored as a minus b times a plus b. This has been taught to you in integrated 3 before, so I know you've seen it, but this is the difference of squares factorization. All right? It's a pattern that we'll call the difference of squares. Now, it gets more involved in this when you think of, really, I'm talking about anything being squared minus anything else being squared. This pattern will work. Same exact factors except for the sign switch in the middle. So let's look at one of these that we run into down here, like number 46. This one is a nice starting point. 9y squared minus 16. The key here is to think of these as a quantity squared minus another quantity squared. So I've got 3y quantity squared minus 4 squared. Well, here's my a and here's my b. Now my pattern works. I have 3y minus 4 times 3y plus 4. So 16 minus x plus 2 squared. So think of it as a difference of squares. It's 4 squared, and then this one's already factored, x plus 2 squared. So it'll be a little bit bigger, but you'll have 4 minus quantity x plus 2 times large quantity 4 plus quantity x plus 2. Do I leave it there? Well, you've certainly shown good work up to this point, but you could take it further. As you imagine, there are like terms in each of these that we could combine. You've got a negative in front of the quantity here, so we need to go 4 minus x minus 2, and that'll just be 2 minus x if you combine the 4 and the negative 2. And over here, there's no negative, it's a positive 1, so I end up with 6 plus x when I combine like terms. So this is probably the most simplified factorization. I keep moving. First thing you're going to do is expand the factored form. I am recording you. Ambient noise, people. Now, it's pretty daunting at first because what you're going to want to do is look at the multiplication, one product of binomials at a time. So we'll do our typical FOIL process here.
Are you writing with your finger? Isn't it hard to do that?
And we get 4u squared. I am recording. Thank you. Minus 2uv. Minus 2uv. Plus v squared. So we end up with 4u squared minus 4uv plus v squared. Now, that looks like a v there. The thing of it is, come on. Now we have to bring this thing down up here and multiply it through this trinomial that we have, okay? So I'm going to have 3 rainbows on top. You know how this goes, right? And that'll give me, hang on here. Here we go. I need a little bit more room here. You'll have 8u cubed. Then in the middle you get minus 8u squared. That's kind of an ugly squared, sorry. V. And then last rainbow on the top there is 2uv squared. Okay, bottom set of rainbows is, thanks, glad you made it, is negative 4u squared v plus 4uv squared minus v cubed. So the reason I stack the like terms that way is, is so I can pull just kind of in an adding kind of way. Now I have 8u cubed. This is minus 12u squared v. Notice the powers aren't changing because I'm just dealing with coefficients when combining like terms here. Plus 6u v squared minus v cubed brings us to the end. Okay?
Why do you negative 8 squared after, why don't you like combine these?
Which v's are you talking about?
After negative 8 u squared over negative 4 u squared, why is it just a v?
Right here?
No, before that.
Right here?
Where'd you get the yeah, why is that v? It's like v.
Well, because it's this v, this negative v times this 4u squared. That's the first multiplication. So you only have one power of v in that product. Negative v times 4u squared.